Hello, this is solving systems of equations by graphing, example 2, and we have two equations to solve simultaneously. This is often called two equations and two unknowns because there are two equations and the two unknowns are the two variables x and y. To solve by graphing, you graph these two equations. We've been doing this for a while. The graph of this equation is a straight line. Same thing with this one. You can use any of the graphing techniques to solve this system. The first equation looks like a table of values, might be pretty simple. If x was 7, y would be 0, and in that way you could get a table of values. If x was 0, y would be -7, and so forth. The second equation, you could get a couple of intercepts, or you could put it into slope-intercept form. But anyway, these are the graphs of the two equations. The first equation is this red line. The second equation, the graph, is this red line. And where the two lines intersect is the solution. And that point, the x value is 1, 2, 3, 4, positive 4, and the y value is negative. It's negative 1, 2, 3. So the solution is 4, negative 3. And graphing solutions are always approximations. You don't know if that 4 is really 4.0001. You just read it from the graph and it looks like it's 4, 3, but it might be a little bit different. So it's traditional to check these graphing solutions. I set up the first equation for substitution, just putting empty sets of parentheses for the variables. And I'll put x equals 4 and y equals -3 into my equation. This becomes -4 minus 3, and you can see that that equals -7. And similarly for the second equation, I have empty parentheses for the x and the y. I'll put in the 4 for the x and the -3 for the y. And this works out to 4 minus 12 equals -8, and you can see that the solution also checks in this equation, because 4 take away 12 is -8, and I've shown that the solution is 4, -3.